Okay, today we're going to talk about slope. I'm going to share my document cam with you. So slope is something that I believe we've been visiting in 8th grade math quite a bit lately, so hopefully it's not a new topic to you, but if it is, that's okay too. We're going to go through each kind of little piece of slope. We talked about slope yesterday as well when we were graphing our tables, when we noticed that kind of constant rate of change. And that's the definition of slope. So slope is a rate of change. Okay, that's our definition of slope. So when we get to word problems, things like that, whatever our constant rate of changes, many times it says like per week or per month. Okay, that's our rate, that's our slope. When we think about slope in terms of how we're going to find slope, there's a few different things we think about. So many times you hear rise over run in how we determine slope. So how much is the graph moving up, down, and how much is the graph moving left, right? What is the rise and what is the run? And we have a formula for slope, which is, and we'll cover it more in a minute, but you may have seen this formula before, y2 minus y1 over x2 minus x1. So there's our formula for slope. So rise over run, rate of change. Notice that I put m here. So we use the variable m to represent slope. Like across the board. So even when we write in an equation and we find our slope, m is the variable used to represent slope. Okay. So when we're looking at a graph, and this graph copied funny for some reason, and we're trying to determine the slope, we are looking at the rise over the run. And so the rise is how much I'm moving up, down. And so if I rise up, then that's a positive. My rise, I'm going down, that's a negative. And if I run to the right, then that's a positive run. If I run to the left, then that's negative. And so I can look at a graph and then determine what my rise over my run is. And it doesn't actually matter what point I start with or what 2 points on the graph I use. So when I'm using the graph to find slope and I'm using rise over run, I just need to be able to identify 2 points that are crossing evenly on the graph. And then I literally just count units of the graph to count the rise and count the run. Now, this graph, of course, copied funny. So there's like a space here, 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 and so on. I don't know, every other line like got missed. So I have 2 points that are identified for me. So I have this point and this point. And if I started at this point to the left, I could go, okay, well, can go down 1, 2, 3, 4. So because I went down, that would be -4. And then I run 1, 2, 3, 4, 5. And I went to the right, so it's a +5. So going from the left to the right point that's identified, I went -4 for my rise, 5 for my run. And so I can write that as my slope, m, is -4 over 5. And so our slope is a fraction, rise over run. Okay. I could have also started at the point to the right. If I had started here, then to get to my other point, I would have gone up 4. So that's +4. But then when I do my run, I would go to the left, which would be -5. So it would still end up being -4/5. Okay. It doesn't matter which point I start with. It's just going to flip which one of these is looking negative to me on the graph. Okay. What you do want to be careful of, like I could have drawn in my run first and then my rise. Sure, that could have also worked, but I don't want to flip around the fraction, right? So the rise always has to be in the top. The run always has to be in the bottom of that fraction that we create with slope. Okay. Now, when I look at my lines, I should be able to identify some basics of the slope just looking at it. So a line with a positive slope rises from left to right, meaning if I have a line and its slope is positive, then it looks like this, like you're going uphill. And if I look at the graph and the line is going downhill, then I should know that my slope is a negative number. So going back to our example here, I can see that this is a negative slope. Visually, I can see that. And so I should double check myself that the numerical answer for slope that I gave matches visually what's happening there. Visually, it's decreasing from left to right. It should be a negative slope. Okay, so that's good that we have a negative slope there. Now we also have slope of zero slope and a slope that's undefined. And so this might be something that's newer to some of you. And so a zero slope means there's no rise over run, and it creates just this horizontal line. There's no increase up, down. I'm just going across this way. And so if I think about rise over run, now obviously I'm moving horizontally, okay? But if I were to find slope using my slope formula or look at it another way, what would happen is I'd get 0 in the numerator and maybe a number in the denominator if I was doing this not graphically, but using my slope formula. Okay, that's what it looks like when we solve a different way, okay, where we have 0 over a number, which is just 0. If I have an undefined slope, that means that there's no run. So let's think about why that would be undefined. So if it's vertical, that means I just have this up-down movement happening, and I'm not going left to right at all, which means if I think about the rise over run up above, my run is 0, and I cannot divide with 0. Okay, it gives us an error in a calculator if we try to do so. I can't divide by 0. So that's one way to think about why this slope is undefined. Another way to think about it is that vertical line test that we talked about with functions. If I drew a vertical line on top of this, I would literally hit every single point. It fails miserably, okay? So this is not a function. This is a function, that's a function, this is a function. This one is not, okay? It fails the vertical line test. For each input here, so let's pretend this is x is at 5, I have 5, 1, 5, 2, 5, 3, 5, 4. That input has all sorts of infinitely many outputs. Okay, it fails the rule for functions. Undefined slope. Here we have a 0 slope. Another way that kids can help remember which is which, I say try to remember this question. So can you walk the line? Okay. If you can walk the line, so yeah, if I was a little person on this page, I could walk along. It's like walking on a flat floor. I can walk along this line. Over here, this is a no. Okay, I'd be falling off a cliff if I tried to walk across. Ooh, I'd fall right off. Okay, this is undefined, not a function. This is a 0 slope. Yes, I can walk the line. Another kind of hint that I give students would be slope man. Now I think at the middle school there's a different slope man, and I don't always remember what it is. I think they do like a face to help remember the types of slope, and they do undefined, I know, is the nose, 0 is the mouth, and then they do eyebrows, and they go negative, positive. I think that's the slope man that you may have seen at the middle school. I do a little guy here. Here's slope man. And slope man's going to go on an adventure where he goes up and down a mountain and he walks along and then, So you notice that my slope man, he doesn't have any eyes. So he's just walking blindly. He can't see what he's walking on. And he starts by walking uphill. And I think we all know how it feels to walk up, especially a steep hill. Okay, you're out of breath. Slope man is having a hard time making up this hill. He's puffing for air. Puff, puff, positive. Okay, if I would think about walking on a line with a positive slope, I'd have to exert some energy. I'm a little out of breath. Then slope man gets to the top and he's going downhill. Now going downhill you don't have to exert as much energy to go downhill, okay? So slope man says, well, this is nice. It would feel nice if I had to walk on that negative slope. I don't have to use a whole lot of energy. It's easy going, nice negative. So slope man, again, remember he can't see, so he's going up, he's going, ooh, I'm really out of breath, this is rough. Then I get to the top, he goes, oh, this is nice, decline. Then he gets here and he's walking for a while, and he says, well, this is zero fun. Okay, because there's just no change up or down, we're just walking on a horizontal line, slope is 0. Slope man, remember, has no eyes, so he just keeps on walking, and he falls right here, and he goes, uh-oh, undefined. Okay, so that's my little slope man story to remember what our different slopes are. So now we're going to go through, we're going to find the actual value of slope for each of these graphs, but we're going to keep all of this in mind. Like for example, on the first one, I know my slope should be negative. So when I get to my numerical answer for slope, it should be negative, okay? Now, unlike the first graph, it doesn't define points. So I wouldn't want to choose a point, like for example here, I wouldn't choose this point because I don't know exactly what that point is. It's kind of floating in the middle of that box. So I'm going to choose 2 points that I think are crossing evenly, although your eyes are probably better than mine. So I think it is crossing evenly here and here. Okay, so I found 2 points that I believe are crossing evenly. One is at 2, -1, and the other is at -3, 2. And looking at my rise over my run, so first of all, I know it should be a negative slope. I'm going down 3, so going down, that's a negative rise. And then to the right, 1, 2, 3, 4, 5. Okay, so +5. And my slope, rise over run, would be -3/5. On the next one, let's see, I think I can find a point here and here. Now visually looking at this, I can see that it's that uphill, it's a positive slope with a rise of 3 and a run of 5. So this slope, and you should be, yes, giving me m equals. Don't just give me a number. What is that number? That number is slope. So it should either say slope equals or m equals, and then the value that you think your slope is. So you can see there are 4 more graphs on this page, and I want you to go through and decide what is the slope for these graphs, and then continue watching the video and check to see how you did. Okay, so let's see how we did. Now, this first one I haven't finished yet, so I'm going to go back to this one in the end. We did have an undefined slope, so there's that vertical line, and a 0 slope, the horizontal line. On this one, we can see visually it's -2/1. I would leave it like this. Like I wouldn't just write it as -2 because I do think when we start graphing, having the rise over run is going to be super important. Now I left this one because I would not leave this. And that's because I can reduce that. So I may, and you may have grabbed a different point than I did. I just happened to grab these 2 points. And so same idea like here or up above, you could grab any point. If I had gone with any of the other closer together points, then I would have had rise of 2, run of 1. I happen to choose this point and this point to look at, which gave me a rise of 4, run of 2. And so if that ever happens, or certainly in a minute when we do this algebraically and that happens, we do want to reduce that to a slope of 2 or a rise of 2/1. Okay, so we want to be reducing those fractions as we go. So that's finding slope from a graph. Okay, that's not too bad. The other thing we need to be able to do is to find slope given 2 points. And so we're not doing this by like plotting the 2 points and finding the rise over run. We're using a formula to find slope between 2 points. And that formula, which you want to like be seeing in your sleep because it really never goes away, ever, ever. It's going to come back to you in Algebra 2, maybe even beyond that. You have to be able to find slope between 2 points all the time for all sorts of things, okay? So slope between 2 points, here's our formula. M equals y2 minus y1 over x2 minus x1. So if I think about my graph, here's my x-axis, here's my y-axis. And if I think about, let me put a line on here. If I think about a line, and I think about my points on that line, okay, when I'm doing y2 minus y1, what I'm doing is I'm saying what's the difference from this y value to that y value? Okay, that this points at some y value, this points at some y value. What's the difference, right? Subtraction's all about difference. What's the difference? Which is really just finding my rise. And then in the denominator where it says x2 minus x1, that's saying, okay, so this point has an x value here, and this point has an x value here. And what's the difference between that x value, which is really just finding my run, okay? So this is still about rise over run, and that might help you remember one of the biggest mistakes is students flipping it and putting x in the numerator and y in the denominator, okay? So that may help you remember that y should be in the numerator and x should be in the denominator, because that's my rise, right? My up down is my y change. My left right is the change in x, okay? And these little numbers here, y2, y1, that just corresponds to my points. So if I have this point xy, I'm going to call this x1, y1. Here's the x value of my first point and the y value of my first point. And then I have this second point, which I'll call x2, y2. Here's the x value of my second point, y value of my second point. And using my formula, the slope between these 2 points, y2 subtract y1, so I'd have 5 subtract 2 in the numerator, and then x2 subtract x1, 1 minus negative 3. Okay, being really careful with those double negatives. 5 subtract 2 is 3. 1 minus negative 3 is like plus 3, gives me 4. So the slope from negative 3, 2 to 1, 5, okay, the rise over run, the difference in rise over run between those 2 points would be 3/4. Let's look at a couple more examples and then I'll let you do a couple on your own. So on A, again, x1, y1, x2, y2. My equation for slope is y2 minus y1 over x2 minus x1, okay? Slope between these 2 points would be 3 subtract 1. Sorry, subtract 0. I don't know why I said 1. 3 subtract 0 over negative 4 subtract 4. 3 subtract 0 is 3. Negative 4 subtract 4 is negative 8. Slope between those 2 points would be negative 3/8. Now B is going to give us an example of what kind of our special undefined zero slopes may look like. So slope between these points, y2 minus y1, 3 minus negative 1, have a double negative there. x2 minus x1, 1 minus 1, gives me 4 in the numerator and 0 in the denominator. I cannot divide by 0. This is undefined. And if you don't write what this means, okay, similar to when you didn't write no solution or infinitely many, I took points off, right? So if you just left the slope here and circled it, that's not answering the question. Like, what is the slope between those 2 points? Well, this happens to be undefined. If it was the other way around and 0 was in the numerator, if it was 0 over 4, then we would say that equals 0. That's a slope of 0. Okay, but when 0 is in the denominator, that's undefined. Can't do that. Okay, so still respond to the question of what's the slope. Don't leave it here. So we have to kind of know what that means. There are 2 more examples here that I want you to try on your own, C and D, using that slope formula. Very careful with negatives. Okay, and then continue the video and see how you do. Okay, so let's see how we did. So on the first one, we do have a double negative in this denominator, so we should be adding. Gives me negative 4 over 4, which I reduced to negative 1 over 1. If you just have negative 1, that's okay. But again, I like to, when I'm specifically talking about slope, I try to write both the rise and the run, even if the run is only 1. On example D, both the numerator and denominator, if we went from second point to first point, gives me this double negative. And we should have had 6/5. One thing that I want to point out, which eventually will probably get asked anyway in class, is does it really matter which point I start with? No. Okay, so I tend to, because it just says y2, I tend to just start with the second point and go to the first point. And then I go x2 and I subtract x1. If I took these exact same points And so I'll just flip them around. So if I had written 1, 3 first, right? Because they're still the same 2 points on the graph. It's going to give us the same graph. Whether I put this point first and that point second, or vice versa, they're still the same 2 points, same exact line, no matter which way we write them. If I had done slope the other way around, where I started on this point and went to this point, that would look different in terms of the work here. But it would have just given me -6 over -5, which a negative over a negative cleans up to +6/5 anyway. So if any of you out there are wondering, does it really matter which point I start with? It doesn't. What does matter is whatever y I start with, that corresponding x from that ordered pair needs to be what I start with in the denominator. Okay, so I have to go, whichever points becomes the leading term here needs to be the same leading term there, has to come from the same point. But in terms of which one I call x1, y1 and which one I call x2, y2, doesn't really matter. Okay. Okay, our last way that we want to be able to find slope is from an equation. And so we've already done a lot of this work. And so I'm going to give you a lot of time to do this work, and I'm not going to talk through all of this part of the notes, is finding slope from an equation. Now we are going to love this form of an equation throughout this unit, which is y equals mx plus b. This is called slope-intercept form. We'll talk more about that next class of an equation. And when I rewrite my equation in y equals, the number in front of x is my slope, okay? And so really what we're doing is we're rewriting in function form, which we already talked about doing. Okay, how do we rewrite in function form? We isolate y. And so if I were to rewrite this equation in function form, I'd have -2y equals -4x plus 6, divide everything by -2, and I'd have 2x subtract 3. Okay, here's my equation in function form. The next thing I'm going to do is identify slope, which is the number in front of x. So for this equation, my slope would be 2. Say m equals 2. I've identified the slope given the equation. Okay. So what we have down here are all sorts of funky equations going on. They're not necessarily set up. This is what's called standard form, where, okay, I move x and then divide by a number in front of y. We see that a lot when we're solving, but not always. And so here, again, my goal is that function form. So even though y is here, I'm going to rewrite this so it becomes y equals. So first I'll add x, which gives me 4y equals x subtract 16. And now I would say it's pretty important to start getting in this habit of writing the variable term and then the constant term when we're rewriting it. So it looks like this, okay? Now I'm going to divide everything by 4, which gives me y equals 1/4 x subtract 4. And yeah, I want to write this as 1/4 and not x over 4, because I want to be able to see the slopes really clearly. Okay, so here's my slope, the number in front of x, and on that first equation, my slope is 1/4. On example number 3, I'm going to subtract 2 from both sides at first. That's going to leave me with 2y. And you'll notice I'm like flipping the equation as I rewrite it, just so it's in the order I want it to be in the end. But I'm just taking this side, writing over here, taking that -4x subtract 2 and writing it over there. Going to divide it all by 2. And y would equal -2x subtract 1. My slope would be -2 over 1. And again, like I said, when I'm talking specifically about slope, I want to provide both the rise and the run. Okay, so -2 in front of x means my slope is -2 over 1. On 5, I would subtract 15. So 2x subtract 15 equals 3y. Now everything needs to get divided by 3. and y equals 2/3 x subtract 5. My slope is 2/3. Okay, so now I'm going to let you try the remaining equations here just to give you some practice, because rewriting y equals in all sorts of funky forms, that's super important skill. Okay, and then also being able to identify the slope from there. So I'm going to pause the video, let you do some work, and then you can check your answers in a minute. Okay, so let's see how we did. I still have to go through and write the slopes for each of them. On 7, rewriting this, I got a slope of -7/2. On 9, -5/3. And so if your signs are off or something's off, take a moment and kind of go back through it. Did you drop a negative somewhere? All that stuff. Looking at the other column of examples here, so I have a slope of 1/5 on 2, a slope of 1/2 on 4. I wanted to make sure to talk about this one. When I rewrite it, make sure you're reducing things. So like I had intentionally left this. So if you have -8/10, then you just need to reduce it to -4/5, but we want the reduced version there. Slope is -4/5. Slope is -1/3 on 8. And last one, slope. So this is our ninja 1, right? So there's really a -1 there. So rise over run, -1/1. So what we covered today were 3 ways to determine the slope of a line. One way is from the graph. My pen is dying. One way is from the graph. So given a graph of a line, I can find 2 points on that graph, and I use rise over run to find the slope of my line. And if I rise up, that's positive. Rise down, that's negative. Run right, positive. Run left, negative. I also talked about finding slope from 2 points. If I have x1, y1, x2, y2, we use our slope formula, y2 minus y1 over x2 minus x1. Okay, so I can find slope from 2 points, I can find slope from a graph, and I can find slope from an equation. And in our equation, we want to rewrite it. It has to be in y equals to be able to determine slope. And that value in front of x is our slope. Okay, 3 ways that we should be able to determine slope given the notes we took today. There's one more thing I'd like to do with you, and you'll see it on your homework as well. And this is a little bit of a push using our slope formula. So what these problems say is it says find a value or x or y that would make it so that the points have the given slope. So now I know my slope is 1/4, and what's missing is one of my variable values. So I have a y value that's missing here. So we know our equation, y2 minus y1 over x2 minus x1. I'm going to use the same equation, okay, where I have y2 minus y1, -4 subtract y over x2 minus x1, 0 subtract 4. Now that equals, or my slope equals this. So I'm going to say, well, that must equal 1/4. Okay, so here's my variable. And what I need to do is solve for that variable. So the first thing I'm going to do is rewrite this. So I have -4 minus y over, this cleans up to just -4 equals 1/4. Okay, I don't like that there's 4's and y's there. It's very hard to see the y. That's my variable. Okay, now we've already talked about how to solve something like this. This is a proportion. So I'm going to cross multiply. I have -4 times 1, or -4, equals 4 times -4 subtract y. And I'm going to distribute the 4 through, which gives me -4 equals -16 minus 4y. And then I can add 16, which is going to give me 12 equals -4y. and divide by -4, and y has to equal -3 here. Y equals -3. Now, we probably could have figured out that if this is -4, and this would have to total up to -1 up here in order for it to reduce to 1/4. So there are some like other mental math ways to kind of work through that. But kind of your best option here to make sure you get the correct y value and that you're thinking through everything that's involved is set up your slope equation, clean it up, then use it as a proportion and cross multiply to solve. So let's look at another example. On 12, I'm missing my x value instead of my y value. y2 minus y1, x2 minus x1 equals -11/8. So when I have a negative, I throw that negative in the numerator for a problem like this. Okay, they're not both negative, just one is. Cleaning up this side of my proportion, -6 subtract 5 is -11. So for example, on this one, I know that this just has to equal 8, and that would be a faster way to get there and solve for x. My other option is to cross multiply and say, well, -11 times 4 minus x has to equal -88, okay, in order to determine what x is. Or -44 plus 11x equals -88. Adding 44, 11x has to equal -44. X has to equal -4. Okay, or I could have said here, well, since these are exactly the same, then this has to be equal. This would have been a faster way, right? Subtract 4, divide by -1. Okay, get x equals -4 that way too. Okay, let's look at one more together, then I'll let you try the last three. y2 minus y1, -2 subtract 0, x2 minus x1, x subtract 1 equals -2/5. Clean up this side of my proportion. So -2 over x subtract 1 equals -2/5. And again, you may be able to see here, like I know this is going to be 6 because it has to be 5 in the bottom since these match totally. So I can see like this has to equal 5. So then x must equal 6. That's totally fine, but show your thinking if you're going to kind of think through it that way. Again, what we have here is a proportion. And how we solve proportions is cross multiplying. So that would give me -10 equals -2 times x minus 1. Or -10 equals -2 plus 2. -12 equals -2x, and x equals 6. Okay, so finding a missing piece here, given the slope, and knowing our slope formula. So now I'm going to let you try 14, 15, and 16 on your own, and we'll be done with notes for today. Okay, let's see how we did. So this number 14 got a little bit funky. Substituting into the slope formula, notice we have this double negative here, so it should become x plus 9. So as I cleaned this up, 3 subtract 0 is 3, and I made this x plus 9 in the denominator. Then cross multiplying gives me x plus 9 equals 9, 3 times 3. And when you subtract 9, you get x equals 0. That's fine, x equals 0 sometimes. I could see how that could throw some people. 15, we also end up with a double negative, so be careful here. Cleaning up this side gives me 3 in the numerator, and I have 5 minus x in the denominator. Cross multiplying, making sure to distribute that 3 through, you should have gotten x equals 3. And then on 16, here's my setup, gives me -10 when I clean up the numerator, when I do y2 minus y1. And cross multiplying, making sure I distribute through to that 7 minus x, you get x equals -9. You'll get more practice with these in your homework today as well. Okay, so keep in mind, this is kind of our golden page of notes right here at the bottom. Okay, we should be able to do these 3 things. And then our kind of push or challenge for ourselves is this last piece, finding the variable given the slope. Okay.